In the previous video, we learnt about what factors and multiples are. So in this video, we are going to move right on to the concept behind prime numbers and prime factors. Now let's do a quick revision of what factors are. A factor is a whole number that divides into another whole number without a remainder. Also remember that any number can be written as a product of its factors, perhaps as a product of two factors or even more factors. Now, how does this connect to prime numbers and what makes prime numbers really unique numbers? A prime number is any number that basically has only two factors, and these two factors are itself and 1. This means that prime numbers can only be written as a product of these two factors, and the only whole numbers that can divide into any prime number are itself and 1. Now let's see some examples by comparing three different numbers, starting with 2. Now 2 can be expressed as a product of two factors, which are 2 and 1. That's why we can say 2 is equal to 2 multiplied by 1. However, when we move on to 8, 8 can also be expressed as a product of itself and 1. That means 8 can be written as equal to the multiplication of itself, 8, and 1. But 8 can equally be expressed as a product of 4 and 2. Then we compare the last number, 11. 11 can only be expressed as a product of two numbers, which are itself and 1. Now this makes 2 and 11 prime numbers. However, 8 is not seen as a prime number. We can also view our prime numbers and our non-prime numbers on our multiplication table. For instance, some prime numbers include 2, 3, 5, 7, and 11. And if you observe carefully, these prime numbers can only appear on the first row or the first column of the multiplication table. You don't see them any other place. But when we compare this to non-prime numbers like 12, 24, 30, 42, 16, we can view these numbers on multiple places on the multiplication table. For instance, let's look at 24. 24 appears on 4 different places on our multiplication table, and this is because 24 can be written as a product of different factors, as a product of 6 and 4, as a product of 8 and 3. Now this confirms that non-prime numbers appear multiple times on any multiplication table. Now that we understand all these, we can now note what prime factors are. Prime factors are factors of any number that are prime numbers. I'm quickly going to use 56 to illustrate this. 56 can be written as a product of 7 and 8. 7 is a prime number and 8 is not a prime number. This makes 7 a prime factor of 56, while 8 is a factor of 56 but not a prime factor. We can explain this further using factor trees. A factor tree is a diagram that is used to represent all the factors of a number, where at the end of each branch can be found a prime number. Let's quickly look at some diagrams to understand this better. We'll begin with 24. Now 24 can be written as a product of 4 and 6. Since 4 is not a prime number, it can be further written as a product of 2 and 2. While we look at 6, 6 is also not a prime number, so it can further be written as a product of 2 and 3. This means that 24 can now be expressed as a product of its prime factors, which are 2, 2, 2, and 3. So the prime factors of 24 are 2 and 3. Let's also look at 42. 42 can also be written as a product of 6 and 7. 6 can further be written as a product of 2 and 3 since it is not a prime number. However, 7 is a prime number, so we cannot write it as a product of any other factor except itself and 1. This means that we can express 42 now as a product of 2, 3, and 7. Hence, the prime factors of 42 are 2, 3, and 7. We have now come to the end of this video. Thank you all for watching, and remember that I post videos like this every Thursday at 12 midnight based on the GMT+1 time zone. I also post math tricks videos on the first Sunday of every month by 8 p.m.